Last time we looked at factoring, we looked at the very first step we always want to do with factoring is our greatest common factor. And then after we've either taken out or not taken out a greatest common factor, if there is one, then we classify how many terms. We saw if we had 4 or more terms, grouping was a good idea on how to approach it. We're now going to take a look if we have 3 terms on how to approach it. Now, unfortunately, if you have 3 terms, you can't always use the method I'm going to use. It has to have a specific form. So to be able to do what's called the AC method, it has to have one of the following forms. It has to either look something like this: ax squared plus bx plus c, ax squared plus bxy plus cy squared, or scary looking ax to the 2n plus bx to the n plus c. All right, it has to have one of these 3 forms. Now that's a lie. There's a lot of other ways that it'll actually work, but these are the ones that we're going to see the most at this time. The first 2, these 2 are actually quadratic, and remember that just means highest power is 2. This last one's a little bit scary because it has these weird letters in the exponents. This has what's called quadratic form. Now don't let this scare you. All this means is whatever the highest exponent is, it's twice as big as the lowest exponent. So if the lowest exponent is x squared, that means the highest would be x to the 4th. So you got like x to the 4th, x squared, and no x's, or x to the 6th, x to the 3rd, and no x's. All right. Now most of the time, most of the time, it's this first form right here that you're going to see. Now notice in all these formulas what A and C stand for. A is our leading coefficient, the number that's out in front, and C is the trailing coefficient, the one at the other end. Let's take a look at one quick example on the idea for this. So let's say if we have this thing, and our directions are the same as last time, and the directions are just factor or factor completely. Now if we're given this, we always want to go through our steps every single time. Now this is the type of questions, and there's a bunch of them, that you need to learn to ask yourself in your head every single time. So when you're looking at this, your first question is there a greatest common factor? In this case, there's not, and I believe last class we were doing something like this to remind ourselves to take that out. Then you say, okay, we need to classify how many terms. Well, up here I see I have 3 terms. If we have 3 terms, I want to use, well, it's horrible, D over there. If I have 3 terms, I want to try to use this AC method. Okay, I want to try to do the AC method. We'll see what it actually is in a second. But before you can start doing the AC method, you have to tell yourself, am I allowed to do the AC method? So does it have one of these 3 forms? Now, the easiest form to recognize is the first one, and that's what we're in right now, right? X squared x and no x's. Easiest way to remember it. So you tell yourself, okay, it has the right form to do the AC method. Now, there's one more question here that's not going to make sense right now. But the question is, can I use the shortcut? We'll see what that is in a minute. The shortcut only works if our lead coefficient is a 1, if the A is a 1. Here our A is a 3, so we can't do the shortcut. Okay, so now that we've determined that we can do the AC method, what is the AC method? Well, the AC method says this. I don't know how to factor something that has 3 terms, but I do know how to factor something that has 4 terms, by grouping. So could I do something like this? Could I break apart this 11x, let's say, don't write this down. What if I said that's 5x plus 6x, right? That's the same thing, right? But now I have 4 terms, now I could factor by grouping. Well, there's good news and bad news here. That's exactly how we're going to approach this. So we need to break apart that 11x into 2 pieces. That middle term, you got to break apart into 2. Unfortunately, there's an infinite number of ways to do it. It could be a 1x and 10x's, 9x's and 2x's, so on and so forth. You can even have negatives, 15x and minus 4x. So since there's an infinite number of ways to do it, we need a way to narrow down our choices, because if it will factor, only one of those infinite number of choices will work. That's where this AC method comes from. Now the AC, what we're going to do is we're going to do some side work. We're going to go over to the side, and we're going to do A times C. Now in this case, our A is a 3 and our C is a 6. So we're going to do 3 times 6, which gives us 18. Now on the side here, write out all the ways that you can multiply and get 18. The easiest way to do this is just start counting. Let's see, 1 goes into 18 18 times, 2 goes into 18 9 times, 3 goes into 18 6 times, 4 doesn't go into 18 evenly, 5 doesn't go into 18 evenly, 6 does, but since 6 is on the other side, you're done. So just start counting till you get to a number on the other side and you're done. So there's all of our ways. Now here's the great news for this. From the infinite number of ways to break this apart, we've narrowed our choices down to 3. So do we see a pair of numbers up here? Because remember, they have to multiply to give us 18 and add up to be 11. Because that's what we got to do. They got to add up to be 11. And you can see a pair does work. That pair right there, 2 and 9, right? 2 times 9 gives us the 18. That's what we needed. And 2 plus 9 is 11. So now, if I rewrite that middle term, as doesn't matter what order you put these in as 2x and 9x, I now have 4 terms, and now factor by grouping should work. So let's go back out of the first, we're going to do first pair and second pair. Out of the first pair, I can take out an x, and I'm left with 3x plus 2. Bring down the plus. Out of the second pair, I can take out a 3, and I'm left with 3x plus 2. I now have 2 terms. Both of these have a 3x plus 2. If I factor that out, from the first term, I'm left with an x, plus from the second term, I'm left with a 3. All right, I now have one giant term and 2 factors in that term. Our factors are 3x plus 2 and an x plus 3. Now remember, we always want to try to factor more. And if I look at each one of these factors, there's really nothing else I can do with either one of those. So the entire idea for the AC method is break apart the middle term into 2 pieces, so factoring by grouping will work. The AC part just tells you, gives you a clue on how to break apart the middle. All right, let's go back this way and try another one. Let's see if we have, okay, 4x squared minus 8xy minus 5y squared. So always, 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 we want to go down our list. We're looking for a greatest common factor first. There's no number that goes into a 4, 8, and 5, except for 1. And let's see, they all don't have an x or they all don't have a y. So as of right now, we can say that this has no GCF. Okay, now, step 2, how many terms do we have? Well, it's pretty easy to see that we have 1, 2, 3 terms. So I really, really, really want to do the AC method because it works out really nice. But can I? Does it have the right form? Well, it does have 3 pieces. Now here's the way you see the second form we see. Kind of like the first one that went x squared x, no x. This one still does that, right? It goes x squared x and no x. But the other direction it goes y squared y, no y's. So this is that second form that the AC method will work on. So we know we're going to have some side work here. Okay, so if we do a times c here, a times c is going to be 4 times negative 5, which gives us negative 20. All right, so now we got to write all the ways to multiply to get negative 20. Give you a hint, leave the negative off for right now. Let's just work with the 20. So the ways that you get 20 are 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, 5's on the other side, so we're done. All right, so we'll worry about the negative in a second. So remember, we're looking for a pair out of here that will multiply to give me negative 20, but will add up to be negative 8. Okay, so we know to multiply to give a negative. I know that when I pick a pair out of this list, one has to be positive and one has to be negative. And I know when I add them together, the answer has to be negative, so the bigger one's the negative. So I see a pair that'll work. this pair right here will work if I make the 10 the negative, right? 2 times negative 10 is negative 20. 2 plus negative 10 is negative 8. So that pair should work. So we're going to break apart this middle term. Now remember, these are xy, so that's going to be plus, let's see, 2xy minus 10xy minus 5y squared. Notice this thing here in the middle is still negative 8xy's. Now we can factor by grouping. We're going to look at the first pair and the second pair separately. Out of the first pair, it looks like I can take out a 2x, and I'm going to be left with 2x plus y. Minus, there's the minus. The greatest common factor out of the second pair looks like a 5y. Now remember, this is a negative 5y we're factoring out. So let's see, 10 divided by negative 5 would be 2. I didn't take out any x's, but I took out the y. Negative 5 divided by negative 5 is 1. Y squared took out a y, so that's just y. Now, if you're not sure, remember, you can always check this in your head really quick. Just distribute that back in and see if you get right back where you started. Now I have two pieces. What do those two things have in common? They both have a 2x plus y. If I factor that out from the first term, I'm left with a 2x. Minus, if I factor that out of the second term, I'm left with a 5y. All right, now we have one giant term here that has two factors. So this is now factored. Remember, you always want to check real quick, can we factor any more? Really can't do anything more with the first piece or the second piece, so this is factored completely. All right, so the AC method works out really nice and easy as long as you can find a pair that multiplies to get you the what you call A times C and add up to that middle piece. All right, now most of the time I don't like showing students shortcuts, but this is so nice and easy and shows up so much, you're really going to want to be able to do this. So let's take a look at another example real quick. Let's say if I have, now you're always going to want to go through the exact same series of questions every time you work a problem. Step one, is there a greatest common factor? And our answer here was no, so again, I'm just going to do this. How many terms? I have 3 terms. Does it have the right form to do the AC method? X squared x, no x, so I can do the AC method. And can I do the shortcut? Now notice on our last example, I don't think I said it, but in our last example, we cannot do the shortcut because the lead coefficient was a 4. But our lead coefficient for this one is a 1. So that means we can do the AC method. Now, here's the whole idea of why this works. If we were to distribute all of this back out, how do we end up with the first piece? Well, you end up with the first one by doing that times that. And how do we end up with the last one? You get the last one by doing that times that. So, by looking at this, and we've kind of seen how these work, these generally do a binomial times a binomial, 2 pieces times 2 pieces. How many different ways can we multiply and get just x squared? Well, there's only one choice. That's why this works. If there was another number there, say a 4, it could have been a 1 and a 4, a 4 and a 1, or a 2 and a 2. Do you see how there's different choices that could have happened over here? However, over here, there's only one way that you can multiply 2 things together and get x squared. It's got to be an x and an x. Now, you're technically still doing the AC method. It's just we're going to do most of it in our head. Because remember, A times C now, since that's a 1, that's really just A times C. So we're looking for 2 numbers that multiply to give us 12, but add up to be 7. And most of us, with a little bit of practice, can do that just by looking at it. Now, if you still get stuck, if you don't, like, sure, no, I'm not sure what 2 numbers multiply to give me 12, and add up to 7, you can still go over to the side and kind of do the little AC thing like that as well. So let's see if I gave you something like this. Do me a favor, hit pause really quick. Make sure you're asking every single question as you go through and see if you can factor this for me. All right, hopefully you're back. So let's see, there is no greatest common factor. It has 3 terms, so I can do the AC method, and it has the right form, right? X squared x, no x, so I can do the AC method. And the good news is the lead coefficient's a 1, so I can do the shortcut. Now, unfortunately, with this shortcut, y'all love to do it every single time, but it only works if the lead coefficient's 1. All right, I'm looking for two things that multiply to give me a negative 15. Since it's negative, I know one's positive, one's negative. That add up to be 2. Well, let's see, if I do 3 and 5, right, those two will multiply to give me negative 15, and those two add up to be positive 2. All right, now like always, we do always want to check to see if we can factor either one of those anymore, and in this case, we can. So, in our notes here, for our AC method, I'm just going to put the forms that we're allowed to do. So we get ax squared plus bx plus c, ax squared plus bxy plus cy squared, a little bit more, ax to the 2n plus bx to the n plus c. So those are the three forms that we can do the AC method on. I know I kind of squeezed them in over there if they're hard to see. Those are just the same ones I wrote at the beginning of this. Okay, so now we know how to handle something that has 3 terms. How do we handle something that has 2 terms? Well, good news and bad news here. If we're going to factor something that has 2 terms, besides taking out the greatest common factor, of course, it has to fit a very specific form or a formula. Now, the good news is we're just going to be plugging numbers and letters into a formula. The bad news here is you have to memorize the formulas. Here's the 3 formulas that you're going to need. A cubed plus b cubed, a plus b, a squared minus ab plus b squared, and a cubed minus b cubed, a minus b, a squared plus ab plus b squared. All right. Now, all 3 of these have names. The first one's called the difference of squares. Of course, minus means difference, and those 2 things are being squared. This is called the sum of cubes. And the last one here is, of course, the difference of cubes. All right, again, good news, bad news here. You have to know these formulas. So I'm going to go over here, and I'm actually going to write the exact same thing that I just did. 2 terms. We have a special formula, and I'm just going to put them over here so we have a table that's done. Now, as you're doing your homework, you're probably going to want to have this out for a while to kind of remind yourself how to go through your factoring steps. But remember, eventually, you're going to want to have these questions and these steps memorized because you need to know how to do them on your own. All right. So, again, if you're having trouble reading that because it is kind of small, it's really just this I squeezed in over there. All right, now the good news is this is everything we need for factoring at this stage. As long as you follow these steps and know this stuff, that you'll be able to factor just about anything that we run into. Now, let's just start over here. Again, our directions haven't changed. It's factor or factor completely. Let's say I start out with something like this. Now, always go through the exact same series of steps every single time. First step in factoring is greatest common factor. So here we have no greatest common factor. How many terms do we see? 4, 3, or 2. Well, obviously we have 2 terms here. So to be able to factor this, it has to fit one of these 3 forms or formulas. Hopefully it's pretty obvious that it's got to be the one of the 2 with the minus signs. So is that stuff being squared or stuff being cubed? Well, looking at it, that appears to be stuff being squared. Now this middle step, at least for the difference of squares formula, eventually I would say it's okay for you to skip. But at first this was really helpful. I'm trying to fit a formula, and my formula has something squared minus something squared. So I'm going to write this as something squared minus something squared. So what would I have to square to get x squared? Well, that's x. And what do I have to square to get a 9? That's a 3. So if you're looking at this, you can now see, basically what I've done is I can just look at this and see what my A is and what my B is. Now I can just take that and plug it into the right side of the formula. Our formula says A plus B, a minus b. All right, so we are now factored. Now we do want to see if we can factor these anymore, and in this case we can't, so we are done. Now this middle step right here, after a little bit of practice with the difference of squares, most of the time I'm okay if students go from here to here. In fact, eventually you should be able to do that, but it's really helpful at the beginning to be able to break it apart so you can see each piece. So if I gave us something like, do me a favor, hit pause and see if you can factor that. All right, if you're back, let's see how you did. Again, same steps every single time. First step factoring is greatest common factor. We don't have one. We have two terms. That looks like the difference of squares to me, so I want to be able to write it as two things being squared. I need to square an x and a 5. So that's my a and my b. So that factors to x plus 5, x minus 5. All right, one quick last step is can I factor anymore? Don't seem to be able to do anything with either one of those, so I'm going to say that that's done. That is factored. Let's try one, maybe two more here. Let's say I have, all right. Again, hit pause, see how you do. All right, if you're back, let's see. First step in factoring, which, just guessing, some of y'all actually probably didn't do right. We do have a greatest common factor here, and it is 4. So if I take out my greatest common factor, on the inside I'd have x squared minus 4. So I'm going to put this in brackets a little bit easier to see. Now inside there I have two pieces. That looks like the difference of squares to me. The two things being squared would be an x and a 2. So this factors to 4 times x plus 2, x minus 2, right? A plus b, a minus b. All right, one last check. Can I factor anymore? And the answer is no. All right, now I'm actually going to do this a little bit incorrectly because I'm guessing about half of you generally make this mistake. A lot of you might have noticed that the way that it's actually sitting, it's actually a difference of squares now. You forgot to do step 1 and you said, okay, that's two things being squared. That's a 2x and a 4. And you are correct. That's 100% correct. And that is the difference of squares, which means we can write this as 2x plus 4 times 2x minus 4. Also correct. Good job if you got here. The problem is, out of our 3 steps that we have over here, you didn't do step 1 or you didn't do step 3. Because if you look at each one of these, we can actually factor each one of those a little bit more. Out of the first pair, I can take out a 2 and I'd be left with an x plus 2. Out of the second pair, I can also take out a 2 and I'm left with an x minus 2. Now since all this is multiplied together, 2 times 2 gives me a 4. And notice we get to the same answer. All right, of course, you see this was much quicker and easier, so make sure that you're following your steps every single time. All right, let's do one more here, and we'll take a look at the next kind. What if I said x to the 4th minus 81? Again, do me a favor, hit pause for a second, and see if you can factor this. All right, if you're back, first step in factoring is greatest common factor. Good news for us. No greatest common factor. I have two terms. I have a minus between there, so it's either got to be the difference of squares or difference of cubes. Those still look like squared stuff to me, so can I write that as two things being squared? Well, x squared would give me the x to the 4th, and 9 squared would be 81. All right, so it fits the formula, so we can just plug it in. So this would be x squared plus 9, x squared minus 9. Now I'm guessing quite a few of you actually made it here, and again, good job. But you're not done, because step 3 says, can I factor this some more? Now this first one is technically the sum of cubes, but I didn't give you a formula for that yet. We're gonna have to wait on how to factor that for a little bit longer. But this one right here, this is the difference of cubes again. Now I can't factor this anymore right now, but this was actually the first problem we did with these two terms. This actually factors to x plus 3, x minus 3, right? Just go through your difference of squares again. Okay, so you gotta watch out with the difference of squares. Sometimes it will factor a little bit more, so watch out for that. All right, let's keep going here a little bit, and let's do just a couple more. What if I said x cubed plus 8? Okay, so again, following our steps every single time. First step in factoring is greatest common factor. Here we have no greatest common factor. How many terms do we have? Well, we have 2 terms, so that means it's got to be one of our special formulas. And since it's a plus in the middle, it has to be this one if it's going to work. It may not be the sum of cubes, but if it is going to factor, we have to be able to write it as 2 things being cubed. Now, with the difference of squares, kind of easy ones like the x squared minus 9, it's pretty easy to go from here to the factored form, especially with a little bit of practice. These are a lot more difficult. You're almost always, for right now, going to want to write this step here in the middle. So the 2 things being cubed here would be an x and a 2. So according to our formula, this is our a and that's our b. So we're just plugging it into our formula here. Now it's a little bit hard to see, so you may have to look at your notes on this one. There's an easy way to remember these formulas. Now if I were you, would actually remember them exactly the way that I have them written. But if you take a look at this, and I'm just going to write it over here a little bit bigger. We have a cubed plus b cubed. That's a plus b, a squared minus ab plus b squared. Notice that this first term, the binomial piece, looks exactly like this, just without the cubes on it. So our first piece here looks exactly like that without the cubes, so just x plus 2. Now for the rest of this works for both formulas, both the plus and the minus. We're going to square the first term in the binomial, change the sign. Whatever this sign is, that's the opposite. So since this is a plus, our next sign is going to be a minus. Multiply those 2 things together, plus, the last one's always a plus, square the last. So watch how I do this. Square the first, change the sign, multiply these 2 things together, plus square that last. All right, now, if you didn't quite follow how I did that, just remember, all I did is I went into this side, and everywhere there was an A, I put an X, and everywhere there was a B, I put a 2. All right, now remember, we have to finish this off by saying, can I factor anymore? So by looking at this, there's nothing else I can do with the x plus 2. But this second piece right here, that looks like the AC method stuff we just did. Give you a nice little hint. As long as you took out the greatest common factor originally, the second piece of the cubed formulas will not factor more. Okay, so you don't really have to look at it. Now this is a little bit of a lie. Occasionally if you have some extremely complicated problems, you might actually be able to factor that some more. But for anything that we're going to deal with in this course, that won't factor anymore. So let's take a look at another one of these cube formulas, because it really is just plugging in. What if I said x cubed minus 27? All right, do me a favor, hit pause and see if you can factor this for me. All right, if you're back, let's see how you did. First step in factoring is greatest common factor. In this case, don't have any. I see 2 pieces, so it's got to be one of our special formulas. Since it's a minus, either that's the difference of squares or difference of cubes. That appears to be cube stuff to me, so I'm going to write it as 2 things being cubed. Well, that would be an x, and a 3 cubed would be 27, right? 3 times 3 is 9, times 3 is 27. Now all we got to do is plug it into the formula, and here's the way it works. The first piece, the binomial, looks exactly like that without the cubes. Square the first, change the sign, multiply the 2 things together, plus square the last. And you are done. So to factor the sum and difference of cubes, you have to know the formula to do this. Now, factoring is never, ever, ever going to go away. You're going to have to use factoring in every course from now on in every math class that you take. So you're going to really practice this and be as good at it as you can, or you will struggle in the future.